Welcome everyone. Today I'm going to discuss about a very big actually misconception about the existence of carbon-carbon quadruple. We know that carbon-carbon single bond exists. No need to explain, but if you say then I'll explain. And we also know carbon-carbon double and carbon-carbon triple bond also exist. But carbon-carbon quadruple does not exist. Why? Many people give the reason for this. They say it is because of steric reason, like both the nuclei will come closer to each other and they will start repelling each other. But I'm not agreeing with this, because if I write the electronic configuration for carbon, it is 1s2, 2s2 and 2p2, right? These are valence orbital, and if drawing their orbital, it is like 2s orbital and it is 2p orbital. You see here 2p orbital has 3, 2p subshell has 3 orbitals. Okay, if this has 3 orbitals, and yeah, you also know that p orbitals has dumbbell shape like this, but this is like this shape is for one orbital. All the 3 orbitals has dumbbell shape, dumbbell shape, dumbbell shape. Let's say it is px, py and pz. If I give the spatial representation for this p orbital uh, for all the p orbitals, it will be like this. Pardon me drawing. Pardon me drawing. This is, let's say, this is px toward x-axis, this is py. If one is px toward x-axis, other is toward y-axis, then the third one orbital, we know we have third one orbital left here, so it should be toward z-axis. Clear? This is p orbital. This is all the 3 p orbitals. Okay, pz. If this p orbital will overlap with the other p orbital, we know that if other p orbital is other p subshell is drawn, it is like similar to this, toward x-axis, toward y-axis and toward z-axis. Okay, this orbital overlap head to head, and the bond form here is sigma. I will draw it. When head to head overlapping between orbitals is, then the bond is sigma. Okay, one overlapping sigma. Then the two orbitals are left, they cannot overlap head to head, they will overlap sidewise like this. The sidewise overlapping is called pi bond. So one more bond is formed here. Now we have only left here one p orbital, so this yy orbital will overlap here and one more pi bond is formed. Okay, so all the bond formed here are 3 pi bond. If we have to make the fourth pi bond, we do not have any orbital left here, so how will we form pi bond? So this is the reason why p orbital does not form quadruple but only triple bond. Okay, this is not because of steric reason. Steric reason will come then if the orbital have one more, if the subshell have one more orbital, but the subshell have only 3 orbital, and 3 orbital overlapping will give us only 3 bond, not the fourth bond. Okay, I hope this is clear to you. Thank you, keep watching. Okay, I have to add one more thing here. Why I am only talking about p, because carbon has only 2 s2p in valence shell. Carbon does not have any d orbital left. Because of the absence of d orbital, overlapping will occur between s and p, but that is why it can only form, that is why it can only form triple bond. It cannot form quadruple because of the reason of absence of d orbital. Only p will overlap, and p has 3 orbital. 3 orbital overlapping can form only 3 bonds. So that is why carbon carbon quadruple do not exist. Thank you. Keep watching, keep supporting.